Kala and the whole INH for giving me the opportunity to presenting here. It's great to see the great enthusiasm. The topic has not been addressed before, at least when talking about inland waterways. That's going to be my focus on, and I'll try to put or to show you some practical example of our German waterways. I'll make it very brief. German waterways are very important in the transport sector. About 10% of the goods transported in Germany are transported in German waterways. The talking about the large and important rivers in Germany, for example, the River Rhine, the River Elbe, the River Danube going down to the Black Sea, the River Oder on the border to the rivers, 1,000 kilometers of inland waterways. And additionally to that, we have the seaports here, Hamburg and Bremen, North Sea and the Baltic Sea. So generally a very important part of infrastructure. It is, and Germany has a lot on these, of almost 50 billion euro. And all major cities in Germany are located on waterways. So there are many challenges. Coming back to my title, climate change is one of several challenges. For example, the accessibility of German seaports for large vessels in the infrastructure and riverbed incision, sediment quality and management. These are all tasks that have to be accomplished and worked on. The question now is how climate change can affect or has effect on the work that we're doing, and this is a core question. On the European level of the macro regions, and there are two macro regions touching Germany. Okay. Touching Germany, first of all, the Atlantic region, the North Sea part of Germany. There will be an increase in heavy precipitation events, in river flow, and increasing risk of river and coastal flooding. And the other part, the green part, a large fraction of, or large parts of Germany, the continental region, increase in heat extremes, and so on. Yes, just going further, as I mentioned, the European level, the European Union, Germany is a member state of the European Union, has set up a strategy and was written further in 2013, for example, with some accompanying documents about adapting infrastructure to climate change. And this is, let's say, the EU strategy in a nutshell. Some parts are three priorities to do with climate change and climate adaptation. When talking about the European strategy, the German adaptation strategy to climate change came shortly after in 2008 with these aims, national EAS, the adaptation strategy in 2011. There was the Adaptation Action Plan, APA, which defined 4 activities. And one of those activities, the activity 3, activities for which are in the ownership of the Federal Republic of Germany. So the Transport Ministry is the topmost administration for managing or for administering the waterways. Clivas, which I would like to talk about. It took 5 years, cost 18.3 million euro, almost the same in US dollars. 30 projects and 40 staff immediately financed. as it finished, but it's still of importance for nowadays waterways climate adaptation. Participating in organizations, the Federal Governmental Departmental Research Institute for Engineering. And additionally to the 40 staff, we had 110 additional workers on this project through cooperations and contractings with universities and other research institutes. So what are the key research questions? And what kind of impacts will do we have to fear on mainly cargo capacity and transport costs, sediment dynamics, for example, for sediment management, ecological and environmental assets as well. Considered, and this was the project structure. 5 research tasks. Task 1 on climate scenarios and projections, and then the other 4 divided by inland and coastal area on hydrology and the water sector. Known from other projects as well worldwide, starting from the emission scenarios of the GCM, RCM, bias correction, and so on, to the hydraulic models, environmental models, until we reach to at some numbers for new model chain or innovative model chain approach. It was said we don't want to have one model chain, but we have a large number of model chains in order to address the uncertainties on all levels that we have. Runs with SRES scenario A1B from the IPCC AR4 climate change scenario set. Over the GCM, RCM down to the hydro and morphodynamic and even environmental models that the so-called multi-model approach. Now let us enter into in the river basins. The 3 major river basins that we have is the Rhine, the Donau, and the Elbe, the Danube and the Elbe. All those important waterways. About 1 to 2.5 degrees centigrade, and in the far future, averaged on over winter and summer, 2 to 5 degrees centigrade increase in air temperature. Winters and drier summers is going to be expected. Wet winters is one problem for flood. Dry summers is a problem for navigation, because you lose discharge and you have a loss in transport capacity. And some orographic data on the River Rhine. The Upper Rhine River here from the Swiss border across the French border here to around this area here. Interestingly, the Rhine crosses low mountain ranges. It's a bedrock river, and then it enters the lower Rhine region here. This is a lowland river, and also on the Dutch side here, very want to have a look at the gauging stations, but in general, summarizing here, for the mean flow, it is projected to increase in near and distant future, and the main driver is MQ winter. In the winter half of the year, the problem is, as I said, maybe there are some days where you cannot transport goods, and that is indicated by the NMS70Q. The definition is given here, down there, an indicator for low flow conditions, and it will have increased frequency of low flow conditions in the far future. Far future 2071 to 2100. Near future is 2021 to 2050. And just extreme flood events, because this is due to the German legislation. The flood protection is a task of the federal states and not of the Federal Republic of Germany. Information from the hydrological chain of modeling, we enter the hydraulic modeling and focus on the Middle Rhine. And just repeating, in the far future, we have severe hazards here because of the model runs indicate this kind of low flow or increase in low flow conditions. And we asked two questions from the hydraulic point of view and asked, will more bottlenecks in terms of possible draft, that means the water depth available for the future? Yes, there will be an intensification. And the second question is, will climate change induce changes in morphodynamic characteristics, at least in the non-bedrock river stretches, but with movable bed? And because that identify and investigate some adaptation measures. Some of them here as an example. First of all, as we always do, river training, more groins, more longitudinal works could help. We thought, okay, let's block this island by, for example, by an inflatable structure, a rubber weir, during low flow conditions, and then use this dammed effect, this impoundment here, to increase the water levels here during low flow. To dredge in the in the bedrock. We say just in case of low flow conditions, we simply reduce the width of the fairway. Maybe no meeting of ship anymore. Maybe one-way traffic, but still. To an economic assessment, that's important for the shipping industry. Some numbers on the traffic and transport on the River Rhine. Currently transported on the Rhine 170 million tons, and the transport cost €1 million per year. And now we said, okay, let's look at the ensemble models here. The model chain that resulted in some change of the transport costs, and say, now look only the costs of 15 million euros per year, or on the red side, increase in costs of about 25 million euros per year in the near future. And in the distant future, we have definitely an increase in costs. And the idea are increase in costs on these different sectors here of the River Rhine, from Basel to almost a German-Dutch border, and saying, okay, one adaptation measure is the optimized navigation or some innovation in shipping. The costs on these relations here, where these measures are applied on the Middle Rhine, and or even together, it enables us to reduce the costs to up to 50%. The effects of climate change. And just to round up the picture, maybe for the environmentalists, just other model results saying that the sediment balance in the River Rhine will not change significantly. Climate-induced effects. And concerning the water quality, there will be a rise projected in temperature, in water temperature, up to 2.5 degrees centigrade. No direct impacts, but possibly secondary impacts. They projected, or they assumed, a sea level rise of 0.8 meters. Currently, the problem is Germany's for the North Sea coast is that there are no reliable projections of sea level rises. So we're really working with this assumption here. and this will increase or decrease in a range from minus to plus 1.1 meter, causing in the estuaries here an increase. And what might happen, or what is the problem then? The greater divergence, for example, to investigate some mitigation measures, they chose the Ems storm surge gate here in the mouth of the river Ems. This is it, and they just applied here, or they investigated the idea and found out that this ground sill will reduce the entrainment of suspended sediment in the river, and also it will reduce the extent of the brackish water zone that is expected to extend due to climate change in the future. The research program. Immediate effects of climate change will not have any significant impacts on waterways and navigation in the near future, but in the distant future we have to be aware. So vigilance is important on the the recommendation to further network not only the water sector of the transport system but also all parts of transport sectors. And this was taken up by the federal government, the transport ministry, and said, okay, let's do another project. Research institutes involved, not only from the water sector but also from the road, from the good transport, and from the federal railway sector, and said you should network and ask or work on. That means they're extending the scope from the climate change issue to much more, but still very important issues and challenges, and also increasing the reliability of transport infrastructures. And currently it is thought about that network and just to highlight what is meant with extreme events, this was what was done in Clivas, and now landslide, storm hazards, and flood hazards, not only concerning waterways but also roads. UK strategy to improve or to address the current challenges. And one topic of this expert network is increasing the reliability of transport infrastructures. Coming back to the waterways, we have old or newly constructed. And now you can put things together, say, if we overhaul or newly construct some structures here, locks, weirs, bridges, the big and the important infrastructure, think about climate change. What is about climate change? It's not a problem in the near future, but in the far future we have to take care. We have challenges here, as I mentioned at the very beginning of my talk. And climate change, yes, it has effect and it can amplify. And this is currently transferred to the Waterways and Shipping Administration. They have already adapted their structure, their administrative structure, and they have climate proofing of waterways. For example, another issue here, or another project, is offering a projection service for waterways and navigation called PROVAS, and also underway the development of a code of practice on the consideration of potential. It's starting right now. Within the German adaptation strategy on climate change, it is said, okay, we need to offer services. And on the leadership of a federal interministerial working group of one is German Climate Services that says give data on climate change and put research on climate change because we need it in the future. And this pillar here, one of two pillars, is the German contribution to the global adaptation to climate change, so-called Klim-Adapt. And everything comes together on the level of research environment, fundamental research, sectoral applied research, and goes down to the federals, from the federal republic to the federal states, then services concerning climate change in the future and adaptation measures in the future. Thank you very much for your attention.